morning students, myself Dr. Shantini Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Kattankuratu, Chennai. Today I am going to start a new topic of digital logic design, is PLDs and PROM. So what is PLDs? PLD is actually the short form of programmable logic device. It is actually the IC that contains large number of gates, flip-flops that can be configured by the user to perform different function. Programming process can configure internal logic gates and or connections of PLDs. One of the simplest programming technology is to use basically fuse. In the original state of the device, all fuses are intact. So what is fuse? I will explain in the next 2-3 minutes. Okay. So PLDs are typically built with an array of AND gates and a array of OR gates. So this is basically the symbolic representation. This is the input, this is the AND array, and this is the OR array. This for in the place of output. So now this is what? Okay, so basically all of you know this is a symbolic representation of the AND gate, and these are basically the inputs. So here basically these are basically the array logic symbol. This basically here this type of all lines we will not draw, only a single line, and this type of vertical lines we will draw. These positions, that mean cross sign, is actually indicate the input is coming. If there is no cross sign, that means no input is coming through this line. If there is a no cross sign here also, that means no input is coming through this line. But at that condition, all from the all inputs, the inputs are coming. This is actually 1, 2, 3, 4, 5 input and gate. Okay, here also 1, 2, 3, 4, 5 input. So here 5 inputs are coming. So similarly, this is the symbolic representation of the OR gate. Here also 1, 2, 3, 4, 5 inputs, and here also this cross sign basically indicates the input. Okay, we have to design the PROM and also when we will design PLA, PAL, everywhere we will use this type of symbol. Okay. So, 3 types of PLDs are there. First of all, PROM, PAL and PLA. What are the difference among all these things? First of all, PROM is actually there is a fixed array, fixed AND array. This is called decoder, and also programmable OR array at the output side. In the case of PAL, there is a programmable AND array and fixed OR array. And in the case of PLA, there is a programmable AND array and programmable OR array. Okay. So in this video, I will explain only PROM. In the next 2 video, I'll explain one by one what is PAL, what is PLA. So keep watching all the video. At the end of, if you watch all this video, you can it will be more clear to all of you. Okay. So starting with programmable read-only memory, PROM. Okay, so before going to PROM, what is ROM? ROM is actually the memory device that collects binary information permanently. This implies that we cannot change that saved information later. In this case, the ROM has a programmable feature, so it is named as programmable ROM or PROM. This gives the user the flexibility to program the binary data electrically once by applying for the PROM program. In the PROM case, fixed AND array and programmable OR array is there. This is the representation. Now you have to build the PROM in this way. There is actually 2 output, that means these are the following Boolean functions you have to represent. So these are the 2 outputs, F1 and F2, and these are basically 2 inputs are there, A1 and A0. So this is the min term, summation of M1 and 2, and this is summation of 0, 1, 3. So here is basically the truth table. Wherever the 1 is there, basically here it is mentioned. Here basically 0 0 means 0, 0 1 means 1, 1 0 means 2, 1 1 means 3. So here basically in the 0 1, that means 1 position and 2 position 1 is there of the output F1. So here also it is mentioned. So this 1 is represented as A1 bar and A0. So here A1 bar A0 plus this is A1 A0 bar. So here this one. Okay. So this is A1 bar A0 plus A1 A0 bar. Now the F2 is actually 0, 1 and 3 position, actually 1 is there. So this is A1 bar A0 bar is 1, then A1 bar is 0, this is 1 position, and then 3 A1 A0, this is actually 3. Now we have to design, that means there is a one decoder is there. In the decoder we know the basic principle is there is actually 2 input, that means 4 output will be there. So 4 output means there is a 2 input and enable input, this is actually enable input. Enable input means if enable input is 1, then only decoder will work, otherwise it will not work. Okay. So A1 A0, based on the combination of A1 A0, the proper output will select. So when 0 0 combination is there, then this 0 line will active. When 0 1 combination is there, then 1 line will active. In this way actually, so here actually A1 is actually MSB and A0 is actually LSB. So 0 0 means 0, 0 1, that means A1 is 0, A0 is 1, that means 1, then 1 0, that means A1 is 1 and A0 is 0, that means 2, and both when 1 1, that means at that position the output 3 will select. So based on this outputs are written. Now from there all lines we will basically draw, and then there are basically 2 output F1 and F2. So 2 OR gate we have drawn. Okay, and we make a vertical line through this horizontal line. Then we have to make a connection. So where we basically make a connection, so we have to see where what is the F1 output. F1 output is A1 bar A0, that means this line A1 bar A0, we have to make a cross sign here. Cross sign means I have already said that means there is a connection is there, and then also A1 A0 bar. So this is actually A1 A01. So there is cross sign, there is cross sign. That means these 2 lines are basically passing through this OR gate. That means F1 is actually A1 bar A0 plus A1 A0 bar. No connection in this line, that means A1 bar A0 bar, and in this line A1 A0. Okay. Now F2 also, F2 is A1 bar A0 bar. So we have to make a cross sign here, then A1 bar A0, so this is actually A1 bar A0, then A1 A0, so this is actually A1 A0, so there is no connection A1 A0 bar. So this cross means there is an input, so these 3 inputs are connected when passing through this OR gate, and output will come F2. So I hope all of you can understand, this is the basic logical representation of the PROM if there is a following function is like that. Now I have given another example there where you have to implement full adder circuit using PROM. Okay, so this is a full adder block diagram. This is where there is basically 3 inputs A, B and also C in, and outputs are sum and carry, and this is actually the full adder sum and carry truth table, where basically sum is actually explained in such a way that wherever the 1 is there, it is mentioned in this way. That means in the position of 1, in the position of 2, then 4, then 7. So in this way here also it is written. Okay, carry also written based on this output or based on this truth table. Now the what is the next step? Next step is we have to draw based on this. As there is a 3 input, that means 3 input, that means 2 to the power 3, that means 8 outputs are there. So 0 to 7. Okay, so here I have already mentioned, that means 0 0 0 means A bar B bar C bar, then A bar B bar C, and in this way if we continue, then it is ended with A, B, C. So these are basically their 3 input. This is enable input. If enable input is 1, then only decoder 3 to 8 decoder will work, otherwise it will not work. So based on this 3 input, A is basically here, A is basically the MSB, C is basically the LSB. So you have to remember this thing, and after that this is 0 is A bar B bar C bar, 1 is A bar B bar C, 2 is A bar B C bar, 3 is A bar B C, then 4 A B bar C bar, 5 A B bar C, then 6 A B C bar, then 7 A B C. Now we have to make a connection. So how to make? There is some these are basically the output lines. There is some, we will extend this line, horizontal line, in this way, and there is basically 2 outputs, sum and carry. So we will make 2 basically vertical line, and also 2 OR gate is needed. So for one is for sum and one is for carry. Now we have to actually make a connection. For the case of sum, which basically input will actually add. So here it is meant, this is actually the summation. A bar B bar C is there, one component. So where it is, this one, A bar B bar C. So we will make a cross sign here. Then A bar B C bar, this is actually A bar B C bar, we will make a cross sign here. Then A B bar C bar, we will make a cross sign here, and another is A B C, we will make a cross sign here. So that means I have already said cross sign means these are the connection, and without cross sign means there is no connection is there. So there are basically 1 2 3 4, that means 4 inputs are connected to this OR gate, and output will be sum. Now carry also same. There is a bar B C, this is the line of A bar B C, so we will make a connection here. Then A B bar C, this is the line A B bar C, then A B C bar, this is the line A B C bar, and last is A B C. So this is the line of A B C. So other position there is no connection. Cross sign means is connection. So these 4 inputs are connected through this OR gate, and output will be carry. So hope all of you can understand how to design PROM, and what is PROM, what is PLD. But still, if you have any doubt, then give me this doubt in the comment section. I will try to solve this doubt. Thank you. Keep watching. Thank you so much.